Hello, DAGD 420. I hope that you've had a great spring break. I spent my spring break producing lots of content. My goal was to make 1 or 2 tutorial videos for each of my classes, so I made scripts, graphics, and lots of code. And when the time finally came to record the videos, my video capture software suddenly and irreversibly stopped working. My work computer is now with the IT department, and they're working on fixing other unrelated issues. So, in lieu of tutorial videos, I've decided to modify and release to you some of the content that I've prepared. This podcast will be as close to a tutorial video as I'll be able to produce. We have lots to talk about, so let's get into it. State of the midterm. I've posted grades for the midterm projects. To adequately assess your projects, I've carefully considered the original RFPs, your proposals, your milestones, my critiques, and your deliverables. So take a look at your grades. If you earned an A, I think your project is good quality for student work. If you've earned a B, I think your project is decent quality for student work, but there's clearly room for improvement. If you've earned a C, you've technically met most of your project's goals, although I think you should really keep working on the project to improve its quality. If you earned an F, your project fell short of meeting its goals, either as stated in the RFP or as stated in your proposal, or there's a deliverable that you still haven't submitted, for example, your process book. In addition to providing you a letter grade, I've also given you quantitative feedback with an evaluative rubric, and I've given you some qualitative feedback by making comments in your process book document. Be sure to download those and read my comments. Grades. Please check your grades on Blackboard. You can also check your midterm grades on MyFSU. These midterm grades are an approximation of your standing in the course. If you're missing assignments, your midterm grade will likely reflect that. But to be clear, when the course is over, if you are missing or have failed any assignments, you will not pass the course. So please remember to continue to work on and resubmit your projects to improve your grades. Remember, your final course grade will be equal to the lowest project grade you've received. The lesson I'm about to give will be primarily just audio. Coincidentally, the subject matter is also primarily about audio. After listening to the lesson, your homework due on the 25th of March will be to create your own audio visualizer. Please see Blackboard for specific instructions. Your other assignment will be to submit and present a proposal for your final project. Your proposal and presentation are due April 1st. Due to technological and logistical problems, this will be the only lesson before April 1st. Today, we're going to use a third-party library to help us visualize audio. In processing, navigate to Sketch, Import Library. In this submenu, we're looking for a library called Minim, M-I-N-I-M. The library probably won't be listed for you. In this case, click Add Library and type Minim into the filter. Select Minim from the list and click Install. Now that the Minim audio library is installed, you should be able to open and run any sketches that use it. Download my SimSketches repo from GitHub at github.com/nickworks/simsketches. While that repo is downloading, let's talk about what audio is. On a physical level, audio is compressed waves of air that cause your eardrum to vibrate. How quickly the waves alternate between increased and decreased levels of pressure determines the pitch or frequency of the audio. We can chart these waves on a graph and see the changes in pressure over time. Let's open the Audio Waveforms 1 sketch. Run this sketch and use your mouse position to control the amplitude and frequency of a sine wave. Make sure your speakers are on so you can hear it too. Press the W key to add another wave to the first. Your mouse position will now control this second wave's amplitude and frequency, and you will see and hear the result of combining the two waveforms. Play with this sketch to see how many unique sounds you can create by simply combining sine waves. All sounds we hear can be graphed as a waveform like this. Open up the Audio Waveforms 2 sketch to visualize the waveform of a song as it's playing. When you run the sketch, the waveform passes by quickly. On a computer, a waveform is saved as a series of numbers, and each number is the next Y value on the waveform graph. As the song plays, those numbers are streamed to your computer's audio device. In order to have smooth playback, we actually have a buffer of numbers stored in the audio device. In my code, I tell Minim to buffer 2048 values. This is larger than what is necessary, but I wanted to display a large chunk of the waveform at a time. This is also why the sketch is 2048 pixels wide. While the song is playing, I access these 2048 numbers on line 40 in my code. Player.mix.get is all I really need in order to get my audio's waveform data. If you want to make an audio visualizer using an audio waveform, use player.mix.get. However, there are other tools we can use to help us generate an audio visualizer. Remember that all sounds are waveforms of compressed air. In the Audio Waveforms 1 sketch, we could create complicated sounds by combining differing frequencies at various amplitudes. Fortunately, we can also go the other way, finding the frequencies that make up a sound at a specific point in time. There is an algorithm called the Fast Fourier Transform, or FFT, that allows us to pull apart a sound and access the amplitude of ranges of frequencies. To see an example of this in action, open the Audio FFT sketch and run it. Here you can see the song's waveform at the top of the sketch. I've also used an FFT to visualize the relative amplitude of bands of frequencies. These are the lines that move up and down as the music plays. I've mirrored this graph vertically so that if you move your mouse horizontally, you can also zoom in to the frequency graph. Most music visualizers use the FFT to analyze frequency data. They take that data and attempt to intelligently interpret it. Even beat detection algorithms typically start by using the FFT. Speaking of beat detection, I want to point out that the Minim library also includes a beat detection class in the analysis package. Consider checking it out as well. This brief introduction should be enough to get you started playing with audio visualization. Be sure to check out the examples in my SimSketches repo. Also, please use the documentation found at code.compartmental.net/minim as you develop your visualizers. If you have any questions, please send me an email. Thanks.